Assalamualaikum, I'm Nadine binti Darman. So today I want to present about Carnot cycle, ideal reversal closed thermodynamic cycle. It represents the maximum possible performance. The history about Nicolas Sadi Carnot. It proposed in year of 1824. He is a French engineer, founder of science of thermodynamic. Also recognized the relationship between heat, work and heat. So the application in the Carnot cycle, the engine that convert thermal energy to work. For the example is refrigerator. It remove of heat from low temperature and dissipating it to high temperature. So it is a reversible process. So it has a 4 basic components such as isothermal expansion, adiabatic expansion, isothermal compression and adiabatic compression. So this is the diagram of the basic component. For at point A, amount of heat absorbed by ideal gas. At point B, system is thermally insulated gas. And at point C, heat loss Q out occur. So at point D, again system is thermally insulated. Next is a working principle. As we can see, the efficient of the reversible heat energy operate between a constant temperature. It between the same two reversor, the efficient of heat energy is always greater than efficient of the reversible one. So this is a cycle diagram. So as we can see, this is 4 basic component in here. So now the advantage is we can get maximum efficient, can get maximum output and decide the possible of any cycle. So for the advantage of the Carnot cycle is impossible to supply heat and also impossible to consume reciprocating heat energy. So next, the last one is suggestion. We can increase the efficiency of the Carnot cycle by decreasing the sink temperature and reservoir temperature. Thank you.
My name is Nuri Fakira binti Muhammad Rozi. So next I will proceed with Stirling cycle. As you can see, this is Robert Stirling. Robert Stirling is a first person that patent for the Stirling engine in 1816 year ago. So the patent also incorporate the first ever description of a closed cycle hot air engine. So next is introduction. Heat engine operating by the and compression of a permanently gases, which is working fluid between different temperature, resulting in a net conversion of heat energy to mechanical work. So we go through the application. Application for this circle is mechanical propulsion to heating and cooling to electrical generation system such as solar power generation and heat pump. Next is basic component. They have 5 basic component. As you can see here, we have a compression space, then cooler, regenerator, heater and expansion space. Working principle. A Stirling cycle engine is a closed cycle regenerative heat engine that operates by compressing and expanding a gaseous working fluid at different temperatures, such as there is a conversion of heat energy to mechanical work. Next, we will go to the cycle diagram. As you can see, they have a 2 diagram over there, temperature and pressure. This is a diagram of Stirling cycle. So now we proceed to advantage and disadvantage of this Stirling cycle. So the advantage is the silence of operation. Second is can run off any available heat source. Constant speed purpose. For the disadvantage is poor shaft efficiently by the existing. Second is high cost and weight. My suggestion for cycle is minimize pumping losses in the working fluid and ensuring effective heat transfer in the regenerator. Keep the maximum value between the hot and cold end of the engine.
Assalamualaikum and a very good morning to Dr. Fadila, our thermodynamics lectures. Today I will present my project C, which is auto cycle. And first of all, my name is Siti Nuruzahida binti Muhammad Idris. My matrix number is B09221110532. Its introduction describes how heat engines turn gasoline into motion. Secondly, the Otto cycle is like the other thermodynamic cycles. This cycle turns chemical energy into thermal combustion, into thermal energy, and then into motion. Thirdly, the Otto cycle describes how internal combustion engines work like automobiles and lawnmowers. The history of the Otto cycle is it was founded by Nicholas Otto, is generally credited with building the first four-stroke internal combustion engine in 1876. Next slide will include working principle, cycle diagram with its figure, the advantages and disadvantages, suggestion and references. So let's start with the working principle of the Otto cycle. The working principle of the Otto cycle has four-stroke engine. The four strokes are intake, compression, combustion, or it calls power, exhaust. The cycle is 1 to 2. It's called adiabatic compression, where you can find from 2 to 3. It is heat addition at constant value, and from 3 to 4 cycle, it is adiabatic expansion and rejection of heat at constant volume. The cycle diagram said of the cycle diagram below the working principle from PV and TS diagram of Otto cycle. Next, the advantages and the disadvantages of the Otto cycle. You can find in an Otto cycle where it is good thermodynamic efficiency. Secondly, it is inexpensive to maintain and build. Thirdly, the Otto cycle has a very good reliability. The disadvantages of the Otto cycle is it has low compression pressure. Secondly, it has less efficiency than the diesel cycle. Where the diesel cycle, we can study it in the next slide. And thirdly, the disadvantages of the Otto cycle, the cycle is not best for engines. Lastly, the suggestion for an Otto cycle. You can more moving parts and manufacturing expertise. And secondly, you can improve by changing its volumetric compression ratio. Thank you. Diesel cycle introduction. First of all, the diesel cycle is a combustion process of a reciprocating internal combustion engine. The history of the diesel cycle. The diesel engine was invented during the Industrial Revolution by a German engineer. His name is Rudolf Diesel. Application in the diesel cycle. The diesel cycle is used in 2-stroke and 4-stroke diesel engine. Second, the diesel engine is used in heavy vehicles like cars, trucks, generator and buses, etc. and many more. The basic components of the diesel cycle you can find at important main parts in the diesel cycle components where it is important in the diesel cycle. First, it is fuel system. Second, you can find the lubrication system, air intake system, exhaust system, cooling system, and last but not least, the electrical system. The figure is shown below the diesel cycle basic component. Working principle. The diesel engine operates by compressing air to high temperature or pressure and then injecting a small amount of fuel into this hot compressed air. Below the working principle words, we can see how the figure is working out.
You can see they have 1 point until 2 point is isentropy compression, point 2 until 3 constant pressure combustion, 3 until 4 is until 4 to 1 is constant volume heat rejection. So next is advantage. There is no cooking in the diesel engine. Second is efficiency. Third is expensive. Okay, next is this. For the disadvantage is increased cost, which is diesel is more expensive to buy at the pump petrol. And the higher purchase price of the diesel car can bump up insurance costs. Second is the driving experience, which is diesel engine tend to be noisier than petrol and high running pressure. So our suggestion for this diesel cycle is increase compression ratio and dilution effective means to increase the thermal efficiency of gasoline engine. Increased compression ratio is associated with issues such as low combustion, increased cooling loss, and engine knocking.
Hello. So the next presenter is me, Siti Nur Syafiqah binti Hamzah. So we will be presenting about Rankine cycle. I will lead introduction, history, application, component, and work principle. So let's go to introduction. So for the Rankine cycle is an idealized thermodynamic cycle that describes how some heat engine operate. So let's go to see about history. This process was developed in 1859 and Scottish engineer William J.M. Rankine. So obviously the name Rankine cycle is actually from him, William J.M. Rankine. So the application is produce heat within a boiler, converting water into steam, which then expand through a turbine producing useful work. So the component is, first we go to pump, and then we go to the next part is boiler, and then we go turbine, and then the last one is we go to condenser. Okay, so about the principle is produce heat within a boiler, converting water into steam, which is then expand through a turbine producing useful work.
Next, for the advantage and disadvantage of Rankine cycle, the advantage is it can improve thermal efficiency. It also the chemical stable, so it is less material requirement. It also reduce steam rate. The disadvantage is Rankine cycle is a very low pressure and high specific volume. It also efficient loss and limited suitability to waste heat recover. So we can see a circle diagram. So to improve the Rankine cycle, we can improve to increase the efficiency. One should increase the average temperature at which heat is transferred to working fluid in the boiler. We also can decrease the average temperature at which heat is rejected from the working fluid in the consider.
Brayton cycle. So let's go for introduction. The operation of certain heat engine that use air or another gas as their operation fluid. As an open system run. So for the history, in 1872, George Brayton sought for a patent for his radio motor. So creating of Brayton cycle. So about the application for gas turbine used to power generator that generate electrical. About the component, first we go to compressor. When we go to compressor, we go to heat exchanger. Heat exchanger it actually have two. First, the hot one and the cooler one. So the heat exchanger, and then we go to the turbine, change it into heat exchanger, and then go to compressor again. Okay, about the work principle is actually compression of the air is isentropic. Combusting is constant pressure, and expansion over the turbine is isentropic, returning the pressure to the initial value. The advantage and disadvantage about this Brayton cycle is the advantage is it's a really compact, better reliable, the variety of fuel. But the disadvantage is higher cost. What need to improve is the last one. The topic is to improve it, increase ratio, so then increase the efficiency of the Brayton cycle. So when we increase the pressure ratio, then the efficiency of the Brayton cycle is up. So that's all from us. Thank you.